Okay, let's continue our discussion of how to find bugs in our code. How are we aiming to find this? We've talked about equivalence classes, those boundary values. We're going to try quite a few of the interior values too. We've got different sort of base, edge, and corner cases. We're trying happy paths and sad paths. What else can we think of? Well, where we often find mistakes. Well, we can talk about, we have logic errors. So again, we've already talked about boundaries. So great. Test around the boundary. Don't just test the boundary, test it plus some around it, as well as those interior values. Great, we've already done that. Equivalence classes, blah, blah, blah. But there are other sort of common sort of things, common inputs. And you can think of them as boundaries. But these are things that often show up, and we've got some sort of notion that this is where we often make mistakes as developers. We've got some minimum or maximum size. Allowed for something or some value. So you could even just think of this like you've got this form on your web page, and and the maximum value is supposed to be 12. But we made a mistake and someone's able to type in 13. And we take it in and we put it in the database. So that's a good place to check. So we screw up at these places like the minimum and maximum. We want to test them that they can go in, but also just outside of them to make sure that they are rejected, okay? There's a lot of things where 0 as input causes problems. Why? Because we often have divide by zeros and other sorts of things, or we don't think about there being nothing in a list. Are we prepared to process an empty list of things? So 0 as either a number or like the size of an array or a list can often cause all sorts of problems. Heck, the value 1. So often we've got a boundary between 0 and 1. We want to at least to have one thing, and so check out zeros and ones. Again, as I mentioned, things being empty. So these are the 0 length list or the 0 length string. You can have empty sets of stuff. They often cause problems because they weren't in our mindset when we coded things. They're obvious choices to try and see. Likewise, people tend to forget about testing things for negative numbers. Think positively, yeah, except the problem is sometimes our inputs will be negative and maybe we didn't code that correctly. Likewise, we often have mistakes at the nth element of an array or list of size n. We screw up. We do things wrong at the ends of lists. We either go one over or one short. Like a huge common problem, for example, is to read a file line by line, and then we forget, we have our logic's wrong and we never actually read and process the last line. Extremely common. So it's like at the end of a list. Think of in terms of these things. What are, almost always at the end of stuff you're gonna mess up. Likewise, besides the nth element, we're likely to screw up at the beginning as well. We might skip the first one when we process things. Or when we're processing them backwards, we might stop too soon. All sorts of these things. It seems like it works because we're computing this and it seems like about the right number. but we might have missed processing something. And we have to have a special, we have to be careful to write our tests to detect when we've made those sorts of mistakes. Those really lead into this general notion. Let's just be explicit about it. We call these off by one mistakes. Okay. So this is, most common when working with arrays. Or any sort of list. So as I just said, we skip the first or last element. And as I also said, it's extremely common to not process the last line of input. Or maybe that's just a mistake that I've made so many times over my life that I've been aware of it, but I've seen it actually when teaching Introduction to Computer Programming. This is a mistake that students make a lot. All right, so just because beginner mistakes make it doesn't mean that experienced ones aren't as well. So these off by one errors catch you all the time. This is especially common when you, in languages like Java, when you're writing for loops. And so you set up the for loop based upon the number of elements, but people mess up with the less than or equals or something along those lines, or they don't start at 0, all sorts of things there. If you do set up an iterator where it's like for each element in the list, you don't make these mistakes as much. So even so, programming ways can help you avoid the mistakes, but nevertheless, we always sort of have to assume those sorts of mistakes are going to be made and we need to test for them. It's real common to have all sorts of numerical errors that we have to look for. So you'll see people make accidental truncation of floating point numbers to integers. So again, this is 1.2, and then it gets truncated accidentally to the value of 1, for example. Very common. I saw mistakes like that in MSci 245 on one of the homeworks where we worked on these book recommendations, and people needed to compute average things and stuff, and or average ratings, and people would make mistakes like that. They really didn't think about it. Likewise, super common, divide by 0. So yeah, my happy path always is I've got a set of things and I'm computing the average, and it works out great. What happens when I decide to compute the average of nothing? Well, you got to deal with these problems. So all divisions should be carefully checked to be sure you're going to avoid divide by zeros. People forget to check, and then we have errors in our code. And so when you're testing, if you're aware of divisions in the code, or a division is happening, think about the way that you could induce a 0 into the denominator and see if the code is able to catch and raise the appropriate error for that mistake. There's all sorts of things where people forget that they're working with floating point numbers. So they code stuff, they make mistakes. So examples of this are they try to add lots of small numbers to a large number. So the problem is when you have a very large floating point number and you try to add something tiny to it, that tininess disappears. So let's say you had millions of these, okay? So you got this big value already, and you're like, wow, I'm going to add in millions of these tiny little numbers and see what it all adds up to the big number. And you keep adding the small number into the big number, small number into the big number, and the big number never changes. And at the end of it, you go, oh, that's the value. Well, the problem is if you really, had that million small values summed together, it would be something that was large enough that when it was added to the large number, would change the large number. People make these mistakes. So you want to think about in the code of catching these sorts of things. Or, again, testing's not always only about our automated tests, but it's also about our code reviews. And so when you read people's code, you should be looking for stuff like this to see are they paying attention and keeping track of what's going on. Also, by the way, we see people assuming that computer math is perfect, and it's not. It's always an approximation. And so, for example, some people will assume that if they've got, the square root of 2, it's equal to, but it's not equal to the mathematical square root of 2. So if we take the square root of 2, this is an approximation to the square root of 2. It is not the mathematical square root of 2. You can even sit down and you can do fun things where you're like, oh, take the square root of 2 times by the square root of 2, find out what that product is, and you'll discover it's not actually equal to the number 2 anymore. So people they forget about this stuff, and it's something that needs to be. This is where mistakes and bugs lurk, and so we're going to find them. There are other ones besides boundaries between equivalence classes. We have boundaries in the system between different parts and components to it. And so often in the integration, we'll have between different components at the integration boundaries, we're going to have mistakes. So this is where, you could even just have it as one system talking to another. And so it thinks it's saying the right stuff, but it's interpreted wrong. And again, we're talking about computers here, but there are these mistakes. And so there can be misunderstandings about what are the proper inputs and output. And when we put together the parts, this is where we'll have a problem and bugs will appear. So the individual components will be fine, but it's in the integration that there's a mistake. Again, this is why we actually have our integration testing and Rails that we'll do. And as well, our end-to-end testing helps capture this. But so we want to be aware that this is often where some bugs will find. We've already talked about don't only test the happy path, also test the sad path. We want to be sure that methods actually reject invalid inputs. That's a real common mistake. So for example, in Java, it's really common for people to forget that the objects being passed in can have a value of null. In Ruby, things could come in that they're nil. And then before you know it, everything goes to pot and the method is throwing problems and stuff. We want to be aware and test to see that our methods are able to reject this. So when we're getting inputs that aren't valid, something should actually happen. Now in Ruby, often we'll get some sort of runtime error, and maybe that's the expected value that we want. And maybe there's not as much testing there, but certainly a lot of stuff in Java needs to be checking that, was I given an actual object? If I was given null, I don't know how to process that. So I should actually raise an exception that says I've been given an invalid input. So we want to test for that sort of stuff. Likewise, other stuff that you want to look for is basically, as I mentioned, null values floating around, in Ruby, a bunch of nils. Is there proper handling of exceptions or throwing and raising of exceptions? We often forget to test about that stuff, but it might be part of the design of a method that when I get this input, I will raise an exception. And so we should actually test that it actually does that if that's part of its design. We should not forget to test that that is sort of a valid output based upon those inputs. And we do have methodologies in our automated testing to check, oh, was this exception actually raised? Okay, good. The method's working as we expected it to. Likewise, we often forget to check and look for, but we should be thinking about what happens to our app. Often, maybe if we lose a network connection, disk goes down, we have power outages, and these might be larger system things, but they could be important things for a large group to be testing. Absolutely, you're working at Amazon, you think about what happens if for some reason we lose power to a data center? Well, they've got backup powers. Well, what if we lose the backup power? We'll still be able to keep running the system by swapping over to another data center. All these sorts of things. What happens in the computer system when the disk drive that we're using to store our data on fails? Will we be able to keep running, or will we have lost data? These are things that, when you're getting deep into your testing that you would be able to consider as well. Okay.